Do not miss any of our cool videos. Subscribe to our channel for latest updates. Click on the bell icon now.
Hey guys, welcome back. This is Moinak from KRSSG IIT Kharagpur, and here I'm back with the second part of the Introduction to Fritzing series. So, if you remember in the first part, we had discussed how we are going to make a simple home automation project which will use an Arduino Uno to control appliances at your home. So, the way this circuit works is that the Arduino sends an input signal to the relay coil, which then connects the load, with help of which any appliance that you want to control, like a light or a fan, would turn on. So the circuit is fairly simple. It's just an Arduino sending a signal to the coil terminals, which is activating the load and which is connecting the load. So we were actually in the process of designing our PCB. So the first concept in a PCB is the concept of layers. So a layer basically means how you are looking at the circuit. So if you have this Arduino Uno, you can see that it has a top surface and a bottom surface. So in a real life PCB, you can have up to 10 different layers where you can actually route wires. Wires are nothing but just copper traces that are etched onto the PCB. So in a real life example, there can be more than 10 layers in the PCB, but most hobbyist applications, 2 layers are more than enough. And if you are actually making the circuit on the perf board, even it is preferred to have the circuit on all the traces on one layer itself. So here I'm going to show you how you can have all the traces on one layer. So let's look at the routing now. So as we discussed before, we need to add male headers so that we can attach our shield onto the actual Arduino. How do we do that? We can search for headers over here. We can also specify that we want male headers here. So again, Fritzing gives you many options over here, but you have to choose the best one. Alright, so you can pick any random option, but the thing you must notice is that how is it actually being mounted onto the board. Here you can see that the pads of the headers are not aligned with you can't fit these headers into your perf board because these are rectangular pads which are meant for SMD or surface mount circuits. Like surface mount, there are 2 types of ICs basically. So there's one type of IC that you can just, like this Atmega chip that you see over here, which you can actually mount onto a receiver that's there on the PCB. And there's another type of IC that you can see over here. Like, you can see this. So it's directly mounted onto the PCB, and it's very hard to solder for any hobbyist. So we generally don't prefer SMD components over here, surface mount device components. What we prefer is through hole components, which we have to look for. So this is a kind of So this kind of header can be handled by our perf board. But the problem with this kind of header, as you can see, is that the pitch is not 0.1 inches. It's more than that. That is why it's not aligning with our with the holes over here. So we can't use this either. So we'll have to discard this also. What do we do then? The only option is to try out all the options over here and then figure out which one is the best one. Alright guys, so after a lot of searching, I think I got lucky and I found this generic header which has 2 pins. So you can see that it's actually it's quite comfortably getting mapped to all the traces over here. So what we can do is just keep placing these components everywhere. So I'll just drag and drop these components over here. please remember that if you don't find a particular part in the library over here, you can always log on to fritzing.com, and there you will get all the circuits, all the different types of libraries that you don't get over here. So I'll just complete the routing and then start recording again. Alright guys, so you can see that I've placed all the different mail headers over here. The problem, as you can see clearly over here, is that the two headers that were present on the shield, which we sourced from Fritzing, were not properly placed, because of which you can see that these are not aligned. But the pitch is still the same, so you can afford to, you can ignore this error for now. So alright, so now that you have all your headers placed, so you have an idea of how your shield, where your of the dimensions of your shield. So you can go ahead and delete this shield, because this is something extra which we added for just for mechanical reference, for dimensioning and all that stuff. So you can remove this because this is not part of our project. Alright, so you can see that you've added so many headers to your shield as well. So we don't need to actually connect all of the headers. We can just go ahead and join one head. Just go ahead and connect one of these pins to our Arduino, and we can connect this resistor to ground. So let's rotate this. Yeah. Then again, since these components are not standard sizes, you will find that these are bent. These are oblique while you are trying to make the PCB. But while routing, you have to be very careful, because this can damage your circuit. Alright. So again, we know that if we look at the schematic of the pinout of the Arduino, you will find that the bottommost pin is on this header is actually 3.3 volts, then it's ground, and then 5 volts. So we need to connect this to ground, so we'll connect this to the second pin, and we'll connect the other one to the coil terminal of the relay. The other terminal of the relay goes to pin number 9 on the Arduino. So please remember that the pin number, it's written over here, it's pin number 9. Alright, so again we can go ahead and wire this up. First you connect it like this, and then you bend it from the middle, and the only thing you have to ensure is that the traces are rectangular, and if they are oblique by a small angle, then it's fine. In the PCB you can, while routing, you can take care of that, but you should, it shouldn't be like 45 degrees or something like this. Alright, obviously to make it look good you can always add bends, but not preferred. So yeah, we are done with routing for now. So suppose you want to etch it on an actual PCB like a perf board. So you can, Fritzing has a very good feature that allows you to make etching very easier. Like when I was a beginner, I often found it very difficult to look at the circuit on my screen and then solder wires on the perf board. So a better solution is to just take a printout of this and then keep it beside your soldering station and do your soldering stuff. So for that you can go ahead and print this actually. Where is that? Yeah, so you can make an etchable PDF over here, as you can see. So what we want is an etchable PDF, so that we can print this and then map it onto the physical circuit. So we'll just make the PDF. Let's place it on desktop. Yeah. Alright, so we have exported our PDF file. Alright, so here we have the layout that we have generated with the help of Fritzing. on in a PDF file. So you can print this and then use it as a reference for actually soldering your perf board, which will minimize mistakes and will ensure that your circuit works fine and there are no like soldering errors or circuit connection errors. Anyways, let's go get back to our design. So once our PCB is complete, we can focus on our code. So the code was exactly similar to what we write, like the Arduino code that we write. So yeah, so the first, as you know that every Arduino code has two parts, the void loop and the void setup. So we'll set that up first. Alright, and we have void loop. So there are no input arguments to these, so you can leave them as it is. So firstly we'll define a few pins over here. So if you remember, in the PCB we have connected pin number 9 to our relay control coin, so we'll define pin number 9 as relay pin. Alright, so pin number 9 is defined as a relay pin, and we'll also define something called the LED pin, so that we can I can show you how alright, I can show you how other things can be programmed using Fritzing. Alright, so we define LED pin as 15. The next thing we do is define the pin modes, like which pin will be set in what mode. So we define the relay pin as an output. Alright, and we can just copy this because we have our LED pin also as an output. The LED pin would do nothing but just keep blinking. That's all it has to do. Alright, so within this we'll just write something like just do digital write. The first thing we are going to do is we are going to turn on the relay. So we'll just write relay pin and we'll let it go high. Alright, so when the relay is turned on with the turning on of this relay pin, we can also set the LED pin to go high. Alright, after this we'll delay the code for some time so that we can observe the on state of the relay. So let's delay it for 2 seconds, which is 2000 milliseconds. Alright, now we can just copy this and repeat the same thing once again, but this time we'll set both of these pins to low. If you remember, then pin number 13 is actually the built-in LED that is mounted on the Arduino Uno board, so we can use that directly. Alright, so we have our code over here ready. We can save that anywhere you want. No, just saving the project. Anyways, you can't save. You'll have to save it, the entire thing, as a project. So let's remove the distraction. And okay, so one thing that you need to do before you actually start coding with Fritzing is to set up your Arduino environment. How you do that is, like, you can go to edit, then to preferences. Over here you'll click this right arrow and go to code view. Over here you need to locate your Arduino installation. This can be quite tricky for some of you because there are many different locations where you can actually install the Arduino Uno package. So I'll just look for it in my C drive, so I don't find it in program files. I look at program x86 and here I have Arduino installed over here. So once you get to your Arduino installed directory, you have to scroll down and just click on Arduino debug. So this will set your Arduino debug source, which will then attach to Fritzing, and this will help us program our Arduino Uno directly. Alright, then let's hook up our Arduino Uno over here. Another thing that you need to do is to figure out the COM port at which your Arduino is connected. So here is my Arduino is connected. So before programming, you need to look for the COM port where your Arduino is connected. So in my case, it's COM4. And alright, so we are ready to upload our code. So before uploading the code, we are being asked to save our project. So we can very well save our project. So let's save it and stop and Fritzing demo. Alright, so once we've saved this, we can go ahead and upload our code. You can see what the log says. Alright, so we can see that the upload failed. We can try to debug this by looking into the error messages that we've got. So we have made some mistakes in like we have made many mistakes actually. So we'll just rectify those mistakes. Alright, so we are good to go. Now we can click on upload again. You can see all the different status messages that are displayed over here. Alright, so it seems our sketch has compiled and the upload has finished. So now that our upload has finished, you can have a look at the blinking LED over here. This orange colored LED that you see over here. So it means that our sketch is actually doing what it was supposed to do. So now I'll just hook up the relay so that you can see it in practice. Alright, so we connect the relay to pin number 9. So over here, what I want you to notice is the clicking of the relay at the same instant that the LED on the Arduino turns on. I hope you can hear the distinctive clicking noise of the relay. So there you go. You've actually created your first real-life Arduino project with the help of just one software, and you've gone from breadboard to code, and you've created an actual PCB that you can use to create a real-life application that can control your appliances. Alright, so this was all for today. I hope you enjoyed the show. I hope I was able to explain in detail about this very exciting software. So in the future, we'll look into how we can use Fritzing to add more functionality to our project. We'll have a series on how you can use different types of sensors to actually get different types of data, and how you can process that data to create more exciting applications. So till then, goodbye, stay home and stay safe. Thank you.